Hello, I'm Floyd Maxwell, justthinkit.com. This video is called Consequences of a Spring and Loop Theory, Quantum World. Beginning at the beginning. Wikipedia is generally a good starting point, so let's quote from the first paragraph of the quantum page. In physics, a quantum is the minimum amount of any physical entity involved in an interaction. The magnitude can take on only certain discrete values. A photon is a single quantum of light. The energy of an electron bound to an atom is quantized, which results in the stability of atoms. As incorporated into the theory of quantum mechanics, this is regarded by physicists as part of the fundamental framework for understanding and describing nature at the smallest length scales. The 80-20 rule. Spring and loop theory can agree with the first 4 points, but thinks quantum mechanics, QM, is non-fundamental in important ways. Let's embrace, at arm's length, the essence of QM, gaining from and clarifying the current view of the quantum world. Kenneth W. Ford's 101 Quantum Questions is well thought out and thorough. Let's dissect it in the interests of science. The supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate representation of a single datum of experience. Albert Einstein. Careful with those building blocks. Ford's introduction lists concepts of the quantum world. Number 1. Quantization. Nature is granular or lumpy, both in the bits of matter that make up the world and also in changes that occur. Number 2. Probability. Probability rules events in the small-scale world, even when we know everything there is to know about the events. Number 3. Wave-particle duality. Matter can exhibit both wave and particle properties. Number 4. Uncertainty principle. There is a fundamental limit in nature in the precision to which certain measurements can be made. The items in red are where spring and loop theory and quantum mechanics differ. The first one of those is number 3, wave-particle duality. Number 5. Annihilation and creation. All interactions involve annihilation and creation of particles. We've formatted that red as well. Number 6, spin. Even point particles, in red, those with no apparent physical extension, can spin, and spin is a quantized property. Number 7, in red, superposition. A particle or system of particles can exist in 2 or more states of motion at the same time. Number 8, antisocial particles. Particles called fermions obey an exclusion principle. No 2 identical ones can occupy the same state of motion at the same time. Because of the exclusion principle, the periodic table exists. Number 9, social particles. Particles called bosons can, and even like to, cluster into the same state of motion, making possible an ultimate togetherness called the Bose-Einstein condensation. Number 10, conservation. Certain quantities remain constant during all processes of change. Other quantities, partially conserved quantities, remain constant during particular kinds of change. Number 11, speed limit. The speed of light sets a speed limit in nature. This consequence of relativity theory is, in red, most dramatically revealed in the quantum world. Number 12, E equals mc squared. Mass and energy are, in red, united into a single concept so that mass can be changed to energy and energy to mass. Another consequence of relativity theory that shows itself tellingly in the quantum world. Number 1, the foundation stone. Housing construction today differs considerably from earlier times. Perhaps the single greatest improvement is the move from dirt floors to concrete. Dirt was permeable to moisture. Sealed concrete is not. Finding a way to keep humans drier also meant we had a chance to preserve things for longer periods of time. Books would never have survived earthen floors. And then where would science be? With the wave-particle concept, physicists today are trying for a dirt-concrete hybrid with disappointing results. Spring and loop theory says particles are never waves. Foundation stone is ethercrete. In COASALT 4, the ether, spring and loop theory explained that the ether, dubbed the universal matrix, is made up of Planck-sized springs of ultra-high energy. With springs 100 billion times smaller than an atom and moving at the speed of light, it is understandable why the ether has yet to be tagged and bagged. In the macro world, springs transmit light and other rays across empty space. In the quantum world, springs have great importance as well. Number 2, nature doesn't waste her time. In a world of just particles and space, annihilation and creation seem like reasonable, if wasteful, activities. But annihilating what isn't there is harder than it looks. Spring and loop theory thinks a photon is not a particle. Why particularize when you can bump? Wikipedia says, quote, a particle is a small localized object. Spring and loop theory says a photon is a bump, one spring hitting another. Two people high-fiving each other in the black hole at a Raiders game. Even more profoundly, a photon never exists. Like gravity, it is an effect only. Number 3, two states is one too many. The notion of superposition, particles existing in two or more states of motion at the same time, is a necessary tenet of the particle-wave-particle hybrid model that makes present-day quantum mechanics so inscrutable. Spring loop systems don't need to behave like spring space, but they are naturally influenced by what the springs are doing. If the springs roll like a wave, the spring loop particles will bob in the surf. Spring and loop theory's non-hybrid approach, while less eco-friendly, yields a more truck-like final structure. And it is trucks, not hybrids, that contractors depend on to build things. I have little patience for scientists who take a board of wood, look for its thinnest part, and drill a great number of holes where the drilling is easy. Albert Einstein. Number 4. Perhaps a minor quibble, but there's nothing dramatically revealed about the speed of light in Mr. Ford's book. The index says speed of light can be found in just 3 pages, in the page 40 to 43 range. Here's a quote from one of those pages. For particle interactions, a useful scale of time is the time it takes light to travel across a proton. There is also a Planck time. This is the time it takes light to travel 1 Planck length. A miss is as good as a mile. The truth is all there in those 2 excerpted sentences. It just isn't put together. Spring and loop theory says that the Planck time is the time it takes a bump of light, or otherwise, to propagate across one spring, which is 1 Planck length in diameter, by definition. So near, yet so far. Number 5. Mass and energy are not united. Present-day QM reveals what it doesn't know when it comes to mass-energy equivalence talk. Mass and energy are not, quote, united into a single concept. Mass cannot be changed to energy. Energy cannot be changed to mass. A man and his money are soon parted, by the right woman. Springs lose their ability to spring in the presence of matter loops. And when matter loops are unrolled, springs are once again free to spring again, with their usual gusto. When you unclamp part of a fishnet, you don't change the clamp into the net. By the way, the man gains more from being in love than from being in money. Clamped can be a good thing. Science is the belief in the ignorance of experts. Richard Feynman. Science reveals the beliefs of so-called experts. Point made. Up. On page 16, Mr. Ford, i.e. quantum mechanics, says the electron, quote, has no size and is a true point. Page 17, he elaborates that an electron appears to be a dimensionless point. This brings to mind physicists telling us a black hole is a singularity. I wonder how many believe such nonsense. All QM can say for sure is, we don't know how big or small an electron is because we can't measure it directly, and our equations give the nonsense result of it being a dimensionless point of size 0. But that doesn't sell very well. Very small bundles indeed. On page 27, we are informed that light exists in bundles. No effort is made to emphasize that this is, in theory. To the best of my knowledge, no one has ever received a light bundle via FedEx, for example. Spring and loop theory says that light doesn't exist. It is a transient effect, like that from striking a bell. When you strike a bell, does the ring exist? In bundles? Physicists are always looking for unifications. Oh, if only that were true. QM disses big G. On page 35, we are told that within an atom, electromagnetism far outcompetes gravity, so much so that gravity can be entirely ignored in the atomic realm. Gadzooks! Given that no one understands how gravity works, how do we know this with such certainty? In COASALT 7, the atom, spring and loop theory said that gravity is what pulls electrons to the nucleus, rather than the plus attracts minus non-explanation miracle. Supersonic air molecules. On page 39, it mentions that air molecules move around at 500 meters per second. That's 1,200 miles an hour, almost twice the speed of sound. Despite my education as a chemical engineer and having made over 50 orbits of the sun, I had never heard this fact before. I'd imagined atoms moving in air exactly like flecks of dust or water mist move, at a few hundredths of a meter per second. Has anyone ever considered that this is incredibly fast? Exploring further, air molecules moving 10,000 times faster than dust grains requires a whole new explanation. I'm genuinely surprised this isn't on Wikipedia's list of unsolved problems in physics. Spring and loop theory would say that once the atoms are freed from the gravitational attraction of one to another, yes, van der Waals forces must be gravitational, they are then easily pushed around by the ultra-powerful, ultra-small, and ultra-plentiful springs they are surrounded by. Calculation. There are 6 times 10 to the 23rd atoms per mole, and they take up 24.5 liters at 25 degrees C. The Planck volume is 4 times 10 to the minus 105 meters cubed. For our bases, we'll have 1 liter of air and springs. This yields 2 times 10 to the 22 atoms and 10 to the 95 springs. 10 to the 73 times as many springs as atoms? Yeah, this could be the reason air molecules travel around at supersonic speeds. The foundation of quantum mechanics will be consolidated or replaced by a more comprehensive one, Albert Einstein. Next up, electron orbital speeds. An electron orbits the nucleus 10 to the 17 times per second, at about 1% to 10% of the speed of light. What causes such a high rate of speed? Conventional physics has no explanation whatsoever. It just is. Spring and loop theory thinks that springs, moving at the speed of light, could cause the smallest stuff in direct contact with them to travel at 1/100th to 1/10th of their speed. It is a reasonable number and is comparable to the speed we can stir a liquid versus the speed the liquid keeps moving at after stirring stops. Congealed gummy bears. Page 41 says mass and energy are really the same thing. Mass is just congealed energy, and energy has inertia, the defining feature of mass. Energy is mass, mass is energy. If mass and energy were the same, the C in that famous equation would have no units. Eating a chocolate bar gives us energy for running, but so does drinking water when we are dehydrated. Yet neither undergo fission or fusion in our body. Quote, C squared in Einstein's equation is a proportionality constant, page 41. Please pass the inertia. Spring and loop theory acknowledges that energy has inertia, but not because it is mass, rather because it interacts with mass, i.e. loops, and matter loops have inertia. The spring energy of space has no inertia, and if it did, we would not be able to coast through it. Statements like mass and energy are the same thing, and mass is congealed energy, reflect what quantum mechanics doesn't know and is just speculating about. Awkward. The supreme task of the physicist is to arrive at those universal elementary laws from which the cosmos can be built up by pure deduction. There is no logical path to these laws. Only intuition, resting on sympathetic understanding of experience, can reach them. Albert Einstein. A charge by any other name. On page 46 it says, but what is charge? You might say that it is that certain something, that je ne sais quoi, that causes particles to have it to attract or repel one another. Most important, charge is what enables particles to emit and absorb photons. That is the essence of what charge is. It couples charged particles to photons. Spring and loop theory says that charge is proof of the ether. The ether couples, quote, charged particles, i.e. spring loop systems, with springs that emit photonic bumps. Stationary states of confusion. On page 54, Mr. Ford reassures us that the wave nature of matter helps clarify why stationary states of motion exist. Look, no matter how strong the desire to immortalize the particle-wave-particle flight of fancy is, saying that particles of matter become waves clarifies nothing. Whether it's the Big Bang's inflationary hack or quantum mechanics' particle-wave-particle dance, spring and loop theory distrusts miracles. No one expects quantum superposition. Page 57. How does the atom decide which direction is up? The startling answer is, it doesn't matter. The ether of springs decides. The springs force particles to be in one of a set number of orientations. When you throw the billiard balls back in their plastic carrying tray, there are only so many places they can go into. Quantum mechanics attributes this to superposition, the idea that a particle can be in 2 or more states at the same time. This is quantum mechanics at its worst. A pint of 100-year-old jitters. Mr. Ford covers the still startling quantum jumps on pages 61 and 62. adding that Albert Einstein repeatedly said he didn't like it, and other physicists have said, in effect, we don't really like it either, but it is a fact of the quantum world. Nothing causes it, nothing triggers it, it just happens. And despite its unpredictable abruptness, it follows all the rules. Extra energetic springs cause quantum jumps. To spring loop theory, it is an electron car choosing to take a different route around the nucleus building. If it goes in a larger circuit, there's an energy and time cost, but the car can do it if it gets pushed into it. Lack of answers is a good thing? Mr. Ford's question 27 is, what is the role of probability in quantum mechanics? He answers with, a starring role. Given that we can't directly measure quantum things, there will always be some element of uncertainty and speculation, but we don't need to know where things are to have a good model. Spring and loop theory doesn't think ignorance is bliss. Muons, the electron's stepdad? Who ordered that? Aye, Rabbi. The Standard Model doesn't appreciate new discoveries. Something about square pegs and round holes, I imagine. Why does the muon weigh? Richard Feynman. So much was the implication. Mr. Ford adds, in truth, no one yet knows the answer to Feynman's question. The Standard Model and quantum mechanics classify the muon as a heavy electron. We could classify Pluto as a heavy brick. It's just a thought. Muonic homewrecker. It turns out that when the hydrogen atom's electron is replaced by a muon, the hydrogen's proton radius decreases. The Standard Model requires muons to be just heavy electrons, and expects muonic hydrogen to be equivalent to regular hydrogen. Instead, the muon breaks the Standard Model. Given that the force holding electrons to the nucleus is gravitational, it is logical to spring and loop theory that a heavier satellite will make the planet more dense. After all, the sun's gravity makes its hydrogen 10 times denser than lead. Spring and loop theory has no problem with the muon. Agreement and foreshadowing. Quote, as entities get smaller, they seem to get simpler. Spring and loop theory is in complete agreement. The photon can't carry a tune. The photon is a force carrier, page 140. Well, not quite. A photon is a bump, an effect. The only thing carrying a force is the spring, as it transmits the bump to the next spring, and the next, and the next. But really, there is no carry. Not so anti. It is just a matter of convention that negative leptons are called particles, and positive leptons antiparticles. In COASALT 6, 222 answers, spring loop theory stated that antiparticles are just another type of spring loop system. It appears quantum mechanics is moving ever closer to the same realization. The truth of a theory can never be proven, for one never knows if future experience will contradict its conclusions. Albert Einstein. An indirect measure of completeness. Quote, the strong force has the most conservation laws. The EM force has fewer conservation laws. The weak force has the least conservation laws. No one knows if the gravitational interaction, the weakest of all, violates still more conservation laws. Page 160. More conservation is good. The strong force is the simplest, the basic spring loop bond. Little wonder it is the most accurately modeled. The EM force is also simple, springs bumping against springs, but it has the widest ramifications and greatest range of effects, earning its second place. The weak force is poorly understood, if at all. Springs letting go of loops and thrashing around violently until they recombined. This is not what we learn in Physics 101, unfortunately. And Big G? Next to nothing is what classic and quantum physics know about it. We can't even model the motion of stars around the Milky Way's black hole. Dark matter is the universe's way of telling us our theories are full of dark matter. Only spring loop theory has a simple model of how gravity works, what it looks like, and how it propagates, and has proposed the truly revolutionary idea that it is gravity keeping nucleons together and causing electrons to orbit the nucleus. The partial differential equation entered theoretical physics as a handmaid, but has gradually become a mistress. Albert Einstein. The Planck verse. Question 65, Mr. Ford talks about the de Broglie equation, where wavelength times momentum equals Planck's constant, making the point that wavelength is a wave property and momentum is a particle property. Has anyone ever considered that the wavelength in question is not that of the particle? If we are to avoid any superposition nonsense, it is imperative to realize that the ether, i.e. springs, are involved. Ubiquiplanck. Mr. Ford then observes on page 175 that Planck's constant, h, appears in every equation of quantum physics. Planck's constant is ubiquitous because it defines the spring, i.e. ether stuff, size. On page 176 we read, E equals mc squared does not contain Planck's constant, h, because it is a classical equation, which happens to be valid in the quantum world as well. The theory of relativity, as I developed it originally, still does not explain atomism and the quantum phenomena, Albert Einstein. So is that reason valid? Or is it because both sides of E equals mc squared are governed by h, and the two h's cancel? Einstein's equation is an equivalence, a relation between two things. Once E and m, i.e. springs and loops, are made relative, h, i.e. size, doesn't matter, and it drops out. Circuit training. Page 177. De Broglie says there are only certain orbits due to destructive interference wiping out most orbital possibilities of these particle waves. Spring and loop theory says that gravity dictates the possible electron orbits, as it does the distances where planets can maintain a stable orbit around the sun. Two planets get too close together and their new gravitational interaction destabilizes them into more distant orbits. Orbital automechanics. The number of routes a car can follow to compass a downtown office building are also finite. It is energetically impossible for a car to drive on anything but roads when trying to circle the block. Travel downtown is quantized. Circumnavigating a building from 2 blocks away instead of 1 is just cincturing in a higher orbit. Quote, the electron is not to be looked at as a particle accompanied by a wave. Rather, it is a wave. Nothing is a wave. The electron is a particle, and the ether of springs is merely wave-like. Quantum mechanics almost gets it. Quote, it is almost as if there is a repulsive force countering the attractive electric force. In energy terms, there are 2 competing effects, page 180. There is indeed a force countering the attractive gravitational force, the repulsive ether spring force. Quote, locked within that rock is an energy, a mass energy of 9 times 10 to the 16 joules per kilogram, page 41. Locked? Yes, this is more like it. Mass energy, on the other hand, not so much. On second thought, the electron's wave nature gets in the way, page 180. No, the ether wave, the 800-pound gorilla in the room wave. Quote, the neutron provides an exception to this rule. It can be slowed so much that despite its large mass, it can have a large wavelength and spread itself over a space as large as that occupied by several atoms, page 181. On the intuitive level, does this make an ounce of sense? The neutron destabilizes the particle-wave-particle concept. Quote, there's something fuzzy about waves, page 182. But springs and spring loop systems are ultra-precise, to the point of every electron being exactly like every other. Quantum mechanics is certainly imposing, but an inner voice tells me that this is not yet the real thing. Albert Einstein. The crux of the problem. Quote, Thomas Young established once and for all that light consists of waves, not particles. Or so it was thought. Waves can diffract and interfere, but particles cannot, went the reasoning. Now, of course, we know that particles can diffract and interfere too. But to give waves their due, particles behave this way only because they have a wave character. De Broglie had it right. Page 183. Strike 1, strike 2, strike 3, strike 4. 4 strikes. Quantum mechanics is out, even with the Black Sox ump. Since light, i.e. spring bumps, is neither a particle nor a wave, all these back and forth mistakes are understandable. Mais où est le bon sens? That's not the lesson taught. Quote, what the two-slit experiment teaches us, and what myriad other experiments confirm, is that a particle acts as a particle when it is created and annihilated, i.e. emitted and absorbed, and acts as a wave in between. To get our heads around it, we just have to give up the idea that a photon is a particle at any moment other than the moments of its birth and death, page 186. Yeah, and we have to inhale very deeply. Or we could adopt a better theory. We've adopted better theories before. Why should this time be any different? If I had to convey the essence of Albert Einstein in a single word, I would choose simplicity. Benesch Hoffman. The preaching will continue. Quote, the wave nature of the electron means that it can never follow a simple track, either circular or in and out. Its wave is always spread out. Page 192. This is not at all how spring and loop theory sees it. Spring loop theory has something, gravitational interaction, affecting the electron. Quantum mechanics says the electron is influenced by mathematics. Who needs a force when you have electron shadowboxing? Preaching will continue until the hypnosis takes effect. The energy is lumpy, page 193. Yes, it is, but why? Because of the discrete nature of springs. Quote, there are some things in quantum physics that we just have to accept, whether we find them reasonable or not, page 194. Spring and loop theory prefers to be unhypnotized. Quote, Planck's constant sets the scale of the quantum world, page 198. It sure does, but why can't we figure out what it says about what the quantum world looks like? Seesaws sicken senior stomachs. Quote, are waves necessary? Not really, page 205. This latest reversal refers to waves being replaced with a calculating all possible paths and their relative likelihood approach. In other words, with probability, which is just as vague. The discussion finishes on the next page with, waves are not necessary, but they are surely convenient. It's another pointless discussion, except to underline how unsatisfactory the particle-wave-particle notion is. I believe quantum mechanics' limitation to statistical laws will be a temporary one. Albert Einstein. Quote, what is going on in the quantum world so closely mimics wave behavior that we might as well use waves to describe that world, page 206. Well, yes, except we attribute the waves to the particles rather than the underlying ether. When will we begin to see the ether? Behind the observations, page 207, question 78. How are particles pushed close to the speed of light? Answered with electrically. The electrodynamic force is springs pushing against springs, so particles are pushed close to the speed of light by spring bumps. Page 209, in a cyclotron, at relativistic speeds, outer orbital paths take longer to transit. Well, outer paths involve more spring interactions than inner paths. At lower speeds, the time for each spring bump is insignificant, but spring bump times add up as you approach Vmax. Electrons, when accelerated, tend to radiate away energy as photons, page 209. Electrons are small enough to be significantly impeded by Planck scale springs. Fermi theory, QM. Question 100. What is the measurement problem? Answer. Shut up and calculate, goes Merman's aphorism, page 259. People don't want to hear the truth because they don't want their illusions destroyed. Friedrich Nietzsche. Quantum mechanics leaves intuition far behind, and so we arrive at the state of affairs today. Collapsing wave functions, aka Copenhagen Convention, page 260, leading to the mind-boggling many worlds concoction. All because the particles become waves become particles, neurons fired long enough for someone to write that down. Why do we spend more time extending bad theories than we do reviewing the impossible conjectures that led to them? This is how it starts. Imagine you have a proton in one hand and an electron in the other. You release them. What happens? They are drawn together by an electric force. Page 180. Look, we can agree they are drawn together, but inventing plus attracts minus doesn't make it so. At best, it is a working placeholder until something better comes along. Spring loop theory says electrons and nucleons are attracted gravitationally. And it peaks with the double-slit experiment. When a wave passes through an opening or by an edge, it bends. That is called diffraction. So the particle must be a wave, at times, but it clearly begins and ends as a particle. So it is both. Case closed. Spring and loop theory thinks diffraction can be better explained by the wave-like response of springs to a particle entering the picture. Luckily, all is not lost. Quote, decoherence replaces the idea of a collapsing wave function with the idea of a quantum system interacting with its environment. Page 263. Eureka! Trust the graybeards. In his older years, Wheeler moved more toward the viewpoint of Einstein, coming to regard quantum mechanics as provisional, as a layer on top of a deeper and perhaps simpler core. Page 263. The tendency of a group of human beings to quickly come to believe something that its individual members will later see as obviously false is truly amazing. Lee Schmolin. Mr. Ford's final thoughts in 101 Quantum Questions is a quote. Behind it all is surely an idea so simple, so beautiful, so compelling that when, in a decade, a century, or a millennium, we grasp it, we will all say to each other, how could it have been otherwise? How could we have been so stupid for so long? John Wheeler.